Welcome to Lesson 12 of Unit 2 Process Validation, and in this lesson we're going to be talking about the V model of validation. We're going to be looking at the validation loop, the V model itself, and we're looking at impact risk assessments and how you perform. There are 5 types of validation that are typically talked about. The first one is the equipment, utilities, and qualification. Second one is your process validation. You've got cleaning validation, QC and analytical method validation, and computer systems validation, and these are commonly called the 5 V's. We'll be talking about some of these in further on lessons. At the end of you have to view it as an integral part of the project lifecycle and not just something that's added on at the end of the investment of a new product, service, or process. So you can actually view validation as being like a loop, starting off with your design, your installation, your operational qualifications, your performance qualifications, and going onwards out through commercial production. You've got your change control implementation. So changes that occur on site must be assessed through the eyes of validation to ensure that changes being made won't affect the validation status of the piece of equipment, material, systems, facility, or utilities. And then you would have periodic reviews of your validation as well to make sure that everything still is in its maintained, controlled state. So that's what they talk about when they talk about a validation loop. So it has to be implemented at each stage of the project to be successful, and it can be viewed as a continuous loop. So there's continuous process improvement going on all of the time, or they should be if your process is working the way it should. The V model is one of the most popular ways of illustrating the stages in a project life cycle. It shows the relationship between the process development and the qualification sides. So you've got your performance qualifications here, verifying what you put into your user requirement specification, your OQ, verifying your functional specs, your FATs, your installation qualification, verifying your design specification here. So it's building on each other. This is a more detailed version of the model. So on this side, you've got your design development, and on this side, you've got your implementation. So you're starting off with your user requirement, the what you need to do, your functional design, your factory acceptance test, how in concept is it going to work, your detailed design, how is it going to be made. Your impact assessment is done at this stage, so you implement your validation plan. So you decide what needs to be qualified, what needs to be commissioned, and you do your installation qualification first. So that's going to verify, did you get your design right? Your operational qualification, including your factory acceptance test, is your piece of equipment or your process functioning the way you had initially intended it to? And your performance qualification, does it do everything that you require to do from your user specification point of view? The V model is a very useful way of explaining how both sides of the model link together and one side complements the other side and they interact together. So qualification is broken down into 5 main parts again. You've got your design element where you're looking at your URS and your user and your process requirements. Your installation part, which is your IQ, your operation part, which is your OQ, your validation, your performance qualification and your process validation as part of that, and then your periodic review, which occurs more frequently than on the site as mandated by your site procedures. Do all aspects of a facility need to be qualified? The answer to that is no. The function of the facility, equipment, or utility will determine if qualification is needed. An impact risk assessment is performed to determine the impact the system and its components can have on product quality and on the patient. This is performed during the design phase. Impact risk assessment. So the outcome of the risk assessment will take place. The systems will fall into one of the following categories. Direct impact. System is expected to have a direct impact on the product quality. So these will be all of your vessels, your heat exchangers, your reactors, your testing equipment, anything like that is going to have a direct impact on the product quality. Indirect system. So systems not expected to have a direct impact on the product quality, but will support a direct impact system. So that might be the likes of your HVAC system, potentially, your purified water system, your heating jackets, things like that may be ancillary but will have an impact on the product regardless. And then no impact. System is not expected to have any impact on the product quality. So if you take the impact spectrum, it might look something like this. If you start off with your parking facilities, that's obviously got no impact on the product quality. Elevators, no impact. Office air conditioner is outside of the GMP areas, so unlikely to have an impact. Chilled water may have some impact depending on what it's being used for. Production air conditioning will have an impact, again, depending on if you've got a clean room environment. It's much more critical than if you don't. General manufacturing area. Building management system then becomes more critical. A piece of equipment like your autoclave could be very critical to your product impacts because you're doing your testing and results on that, and you could be using it for your fill finishes. Purified water system then is actually part of the product, so that is a direct impact. The design and the use of these systems can affect their impact. So where in one particular facility it might be a no impact, in another facility, depending on where it is and what it's being used for, it may very well be direct impact. So that is just showing you these systems again in terms of their impact and their non-impact. System impact assessment, again, would happen during the design phase of the project. So the first thing you have to do is identify what system you're doing. Look at developing your system boundaries, so you have a comprehensive understanding of the product, the process, and the nature of the system. So does the system have a direct impact on quality? If your answer is yes, it's obviously going to be a direct impact system. That's very straightforward. You need to develop your supporting rationale. If your answer is no, it doesn't have a direct impact, is it linked to a direct impact system? If it's yes, it's indirect impact system, then it goes, you do put your developing rationale around that. And if it's no, you decide it's a no impact system and you develop your rationale to support your findings there as well. These would need to be documented and could be called up in a regulatory inspection for verification. So system impact assessment. So if you think about these systems here for just a minute and see, where would you define them? Would you define them as being a direct impact, an indirect impact, or a no impact? Bearing in mind that depending on where they are and how they're being used, they could fall into more than one category. Okay, so a product filter is straightforward. That's obviously going to have direct impact. Vessel heating skid will have an indirect impact because it's heating and cooling the product. Your electronic batch record is a direct impact. Your sprinkler system, depending on where it is, could be direct or indirect impact. Your CIP skid, clean and place skid, is an indirect impact. Could also be direct impact depending on where it is. The laboratory and the offices, the system impact for them, in indirect or no impact depending on where the offices are and what they're doing. And HVAC could be any of the three depending on where it is and what it's being used for. Direct impact systems. Direct impact systems are commissioned and qualified. So the qualification goes through the design qualification, installation qualification, operational qualification, and performance qualification. Indirect systems, they'll support a direct impact system. They're commissioned only and their interfaces need to be carefully assessed. When a system can be used as a direct and indirect system, then it has to be considered direct. So you always take the worst case scenario. If it ever could potentially be used as a direct impact, it must be validated as a direct impact. For no impact systems, remember your good engineering practices. Professional project management has to be carried out by appropriately qualified people. So this is a really important assessment to be making. You don't want any errors in it because it could come back to haunt you. Taking all of the relevant quality and technical standards into account, and that would include health and safety and the environmental impact considerations. So will have no impact on the product quality, then it's designed and commissioned only. So over to you to check your understanding. What is the V model and what are its components? How do you assess if a component is direct or indirect impact? What action should you take if you ascertain a component is of no impact? Thank you very much for your time and attention. We'll see you for the next lesson.